Here's our third homework session for linear algebra in 2D. This one is about determinants and eigenvalues. In the first exercise we have the two matrices from the previous homework again, A and B, where A depends on this value A, little a. And in this exercise you have to compute the determinants of these matrices, and then you should compute the eigenvalues and eigenspaces of this matrix B. 2 is a bit of a theory exercise, so you're given some matrix A and you have to prove or refute the following three claims. First, if A has eigenvalue lambda, then A square has eigenvalue lambda square. B, if A square has eigenvalue lambda square, then A has eigenvalue lambda. And C, if A square is equal to the zero matrix, then the only eigenvalues of A are just 0. Exercise 3 is a bit longer, but a very beautiful exercise where you can see the power of eigenvalues for solving recursive equations. So here we have the famous Fibonacci sequence given by this recursion here. The first two elements, f0 equal to 0 and f1 equal to 1, are given. And then for indices n greater equal 2, fn is given as the sum of the two preceding elements, fn minus 1 plus fn minus 2. Now I define the Fibonacci matrix to be this matrix F with entries 1, 1, 1, 0. And first show that this matrix F has two distinct eigenvalues, gamma and delta. And as a sanity check, you should verify that once you have the eigenvalues, that they satisfy that gamma is equal to 1 minus delta. Otherwise, you will have made a mistake. Next, determine the eigenspaces for the matrix F for these two eigenvalues, gamma and delta. In part C, write the vector 1, 0 as a linear combination of eigenvectors of F. Then in part D, prove by induction on the number n that for n greater equal to 1, the nth power of the Fibonacci matrix, f to the power of n, contains Fibonacci numbers as entries, namely fn plus 1, fn, fn, and fn minus 1. And finally, with everything you've proved so far, in the last part, find a closed form for the nth Fibonacci number. That is, find an expression for this fn that depends only on n, but not on any of the preceding Fibonacci numbers.